What's good, people? Welcome back to my channel. Today I'll be talking about how to make an object move up, down, left, and right. And these are cool little methods that you guys can use in either a top-down or a platformer game. Now, before I continue, hit me with a subscribe and like if you like the work I'm up to. So, before I continue, let me show you what I'm going to be working to show you guys. Here we go. So here we go, we got a little circle right here. That's the object that's going to be moving, and if I hit the arrows you can see that it moves in all directions that I try, right? Now with this method, which I'll talk about later, does not use the rigid body collider, just the rigid body. So that's pretty much what I'll be showing you guys how to move in two different ways. Now what's all in here? Well, basically all I have is just a square background, and the main thing that I'm operating or moving around is this circle, and it's inside basically this game object. And all I have inside this game object is your simple sprite renderer. I added a sprite that's a 2D circle that you guys can add. Let's see what else. I got the script, which I'm going to talk about in just a moment. And of course you got the rigid body 2D when I start moving it based on its rigid body. Now, how did I set this up? All I did was I put a dynamic value for the body type. And also I set the gravity scale to 0, so I'm able to make it move, and when I turn on the game it doesn't just fall straight down. So now let me show you the code and you guys can see what's under the hood. So here we go. We are at the script that causes all the movement. So how did I set this up? So basically I have the floats, which is going to be the X velocity vector position point, and the float that's going to be the Y velocity vector for when we start putting it into the move direction. Now I have also set up the rigid body component, and I've also set up the velocity, how fast this moves, into the little function. So before I start off the whole scene, it grabs the component of the rigid 2 body to be able to move it when I start using that type of method. Now I have two ways to be able to move this, right? So the first way that you guys saw earlier was by using the move by adding to position function that I created. And the second one is going to be using, it's going to be the fixed update call. So in here it's going to be based on all the math that goes on in here with physics. And the reason we put this in here is because we wanted this to fire off once at a time per frame. Otherwise we'll be getting some crazy movement going on in here. So that's pretty much the two ways we're going to be setting this up, and we're going to fire this off in both ways so you guys can see the differences, which you really shouldn't be able to see any of that. So let's take a look at the move by adding to position. This is one way I get things to be able to move when I actually fire this code. So whenever I hit one of the horizontal movement keys, left or right, or up and down, it's going to place a 0 or a 1 in any of these values. So if I am pushing, let's say just left, xvel is going to be 1, or let's see, left, yeah, it should be a -1. And if I hit a up, that would be a 1 for Y velocity, right? So why is that important? Well, it's because you're going to be creating a vector for all this, and the vector is basically going to be just the xvel times the time change times a little bit of a adjuster to be able to get this moving. And whenever you create this vector, it's basically going to be set to the move direction, and whenever I'm done with that, it's going to add it to the position, and it's going to cause it to become the new position, which is added by just a little increment. That's why we got the little plus equals. So it's basically just adding that position each time this is fired up or being picked up. So that's what I did in the first time to be able to show you guys, right? Now the second way I was able to do this, now commonly I guess I've done a game like this before, but I found that it kind of messes up with any physics that occurs. So it will basically take over anything that occurs. So what do I mean by that? Let's say I want to make a object get pushed by a sudden force. Well, if this is firing off, it's probably not going to work. So most of the time you might want to be able to just use the move by adding position function that I have in there, and all that jargon will be able to make you feel the effects of other physics falling upon that. So this is probably a better way to do things. But this is just showing you guys another way that you can do it, and it looks a little bit more easier for you guys, right? I hope it does. So what it does is it grabs the rigid body, it grabs the velocity operation, and it sets it up to this vector that's being pulled. Now if you see I have normalized, it's because if you have the X and the Y being pushed off, it's going to try and move at that rate. but it's not gonna happen because it's gotta be, I guess you could say, it's gotta be the true speed no matter what direction you go, right? So if you're going in a diagonal, it should still have the same velocity, so it prevents us going faster than it should be. And on the side we have the move speed, which is just a scale factor to be making this move by. So let's go ahead and try that one out, and we'll be done with this quick tutorial. So let's go ahead and make that quick little changes. Here we go, I got this all saved. Alright, here we go. Now this is running off of the rigid body. I'll go ahead and hit play, and now it should do every single thing that we just did without using the rigid body movement function, right? Or the little method I created, right? So if you guys like this, go ahead and hit me with a like and a subscribe if you guys like what I did, and maybe you guys can add it to your little game, alright? So thanks, and check it out later.